Dalton described atom as the simplest part of matter. But later on, in the later part of the 19th century, certain discoveries led to the conclusion that atom is not a simple entity. It is a complex unit that is made up of certain smaller parts, which we call the subatomic particles. The very well known subatomic particles are electrons, protons, and neutrons. But these are not the only particles. But of course, these are the fundamental particles that make up an atom. Protons and neutrons are present inside the nucleus of an atom, while electrons are present outside the nucleus in discrete energy levels or shells. Apart from these three fundamental particles, there are certain other particles that can be found in atoms. But these are not the topics of discussion here. We will only talk about the fundamental particles. And as a first lecture in this series, we'll discuss the discovery of electrons, that is through cathode ray tube experiment. So let's begin. J.J. Thomson performed the cathode ray tube experiment back in 1887, through which he discovered the electrons. First, let's describe the experiment and the discovery, and later on, we will talk about certain properties of the electrons or the cathode rays. So, this experiment is known as the cathode ray tube experiment. So, it is performed in a tube that we call the discharge tube, and this discharge tube contains a gas at a very low pressure. So the tube is filled, this glass tube is filled with a gas. It is connected to a vacuum pump and it contains two metallic electrodes, that is cathode and anode. These electrodes are connected to the negative and the positive terminals of a high voltage battery respectively. So cathode is connected to the negative terminal, anode is connected to the positive terminal. Cathode, that is why, is negatively charged, anode is positively charged. And the generator to which it is connected contains high voltage up to 5,000 or 10,000 volts. Now, at the start, J.J. Thomson kept the gas at normal atmospheric pressure. And when he turned on the battery, nothing happened, which means that the gas was unaffected by the high voltage. And then he reduced the pressure to zero point 0.1 torr. And he observed that at this low pressure, the gas becomes a conductor and current flows through the gas and it emits light. But when he reduced the pressure further to zero point zero 0.01 torr, the light disappeared, and he observed that certain rays started to emit from the cathode moving towards the anode. These rays were called by J.J. Thomson as the cathode rays. Because of the fact that these rays travel from cathode, they originate from cathode and travel towards anode, that is why they were named as cathode rays. And because they are attracted towards anode, which is a positively charged terminal of the battery or a positively charged electrode, J.J. Thomson concluded that these are negatively charged rays. These rays were called electrons by Stoney later on. It is interesting to know that cathode can be made of different metals like aluminum, iron, or other metals too. And with all these metals, one is able to create these cathode rays, from which J.J. Thomson concluded that these negatively charged particles or electrons are part of every atom. It's not a single atom or it's not a single element that whose atoms contain electrons, but every atom of every element will contain these subatomic particles, which were called electrons by Stoney. Cathode ray tubes have been used in older models of TV. If you remember the old TVs, the large setup in which cathode ray tubes are fitted and electrons are emitted when current flow, when they are connected to certain voltage, electrons flow and they strike the screen and then create an image on the screen which can be visible to the viewers. Now let's discuss certain properties of the cathode rays discovered by J.J. Thomson. J.J. Thomson concluded that cathode rays are negatively charged particles, and this was concluded from the fact that they travel from cathode towards the anode. And because these are charged particles and they are moving, they are also deflected inside a magnetic field, which means that if you place a magnet near this tube, these particles will be deflected, which concludes that they are moving charged particles. You should know that magnetic field cannot affect or magnet cannot attract or repel stationary charges. The charge has to be moving to be affected by the magnetic field. So these particles were deflected by the magnetic field or the magnet, which meant that they are moving charges and they have a negative charge because they are traveling from the cathode towards the anode. The glass tube that is used in cathode ray tube experiment is coated with a fluorescent molecule like zinc sulfide, and so when these cathode rays they strike the walls of the glass tube, they produce a green glow or a green fluorescence. These rays can also form shadow of an opaque object if it is placed in the path of these rays, which proves that these rays travel in straight line perpendicular to the cathode towards the anode. The rays that are produced from the cathode are said to be particles in nature. So these rays have a particle nature, and it was proven from the fact that if a small paddle was placed in path of these cathode rays, this paddle was rotated by the cathode rays when they strike the paddle, which means that there are certain particles inside these rays, and these particles were later on called as electrons. And you already know that electron has a particle nature as well as it can behave as a wave. When these cathode rays strike the anode, they can produce X-rays too. If you place a platinum foil in front of these cathode rays, heat is produced and the platinum foil it starts to glow because of that heat. Cathode rays, because they are charged particles and they're moving, they can ionize gases as well. And ionization in this case can take place when these charged particles or the cathode rays or electrons, in other words, when they strike the gas molecules, they can eject an electron out of the molecule of the gas and that's create ions from neutral gas molecules. These electrons can also cause chemical change when they are made to strike some material. If you place aluminum or gold sheets in front of these particles or cathode rays, they can penetrate through these sheets. The charge to mass ratio of electrons was later on calculated by J.J. Thomson to be 1.75 into 10 to the power 11 coulomb per kilogram. We'll discuss this in the next lecture how J.J. Thomson was able to calculate the charge to mass ratio of electrons. So this is it for today. Thank you so much for watching. See you next time.